See, in this class, we are going to see testing of hypothesis. We are having a t-test, f-test, a chi-square test, and so on. In syllabus, we have t-test, and in addition, we are also going to see chi-squared estimate for testing the hypothesis. Right? You have already seen it. We'll have a small recap, and for the same thing, we'll be trying to see how chi-square test is also rejecting or accepting the null hypothesis. Right? So that is what we're going to deal in today's class. Yes. So now let us go into the problem. The problem statement is nothing but it is going to have the blood pressure values based on the oral treatment. Oral treatment is the patient have taken some drugs and based on the, some medicine and based on that how the blood pressure actually changes. Right. So I'll write the things over here. So blood pressure before OC, that is oral or OT, before oral treatment. Next, blood pressure after oral treatment. So actually, I'm having the blood pressure values in both the instances. So ultimately, what I can actually say is I can actually understand even after what is the effect of the treatment in the hypothesis. For this blood pressure values before the treatment is what the observed values. Once I do some treatment, how the blood pressure actually changes. So that the entire distribution is changing, or what is the characteristic that is actually changing just because of this particular oral treatment. That is what we are going to estimate the given hypothesis, right? Right. So I'm having the blood pressure values here. Now let us have the questions over here. Now in exam also you'll be getting like a table of value distributions, and from that distribution you need to identify what is the p-value. And if I give any hypothesis, you should say whether the hypothesis should be accepted or rejected. That will be the case, right? If it is a pen and paper exam, you'll be having as a, some 8 marks over here. Or if I directly give a t-value, and you should be able to say what will be the hypothesis, whether the given hypothesis can be accepted or rejected, right? Or what is the probability of accepting? That is the p-value. Everything will be seeing here: 101, 101, 119, 195, 138, 126, 105, 104, 115. Have this. Next, blood pressure after OT, that is after treatment, some treatment, right? 128, 115, 106, 128, 122, 145, 132, 109, 102, 117. So I have the values here. Now for the same blood pressure values, we have the distribution before some situation and after after something happening, the same values how it is changing. So for this distribution, we'll be saying that this distribution will be normal and having this particular hypothesis, we may assume. So after the influence of this treatment, how it is actually changing, that is what we need to say. That is some expected value we are actually having here. Now, what is the effect of this treatment? We need to identify by using the t-test, right? Shall I do that? Have you understood what is the question? Yes, have you understood what is the question? The question is actually identifying about the blood pressure sequences. The blood pressure values is given here before some treatment. Once the treatment is given, the blood pressure value is actually changing. So, what is the effect of that particular blood pressure in the distribution? The distribution is actually taken for 10 people, and for those 10 patients, how the treatment is actually changing, right? That is the effect we are going to study by using the hypothesis testing. Yes, now what we can do, I just take after minus before. That is the difference between the bed pressure after minus before I take. So the same procedure you have already seen. That is 128 minus 115. Similarly, 115 minus 112, I take the difference. I say this is going to be the difference. Difference, that is after minus before. Yes. So this is ready now. Now what we have to do? Now we will be doing these differences with respect to a particular value. Now I will be squaring this difference also because my formula requires square the difference also. So I take difference square. Take difference square. That will be equal to 13 into 13. That is 13 squared, extra 3 squared, minus 1 squared, and so on. I take it, and this is what the initial things I do. I take this sample is actually given to me, and I want to understand this particular distribution. For this distribution, what I take first, I take the value, the difference between the observed values and what is actually expected after a treatment. This is actually the blood pressure after treatment. This is what's observed. So I need to find what is the difference between observed and actual. So I take the difference between observed and actual, and I take the square also. This square is nothing but because my standard deviation formula will require the square. So we are taking the square. Right? Now we apply the formula of t square. Right? The formula of t square first I'll write here. Then I'll be putting a formula for that so that I'll feed the formula into Excel so that we can use it any number of times. So what is the formula for t square? It is very simple as we take the particular sample. For example, my difference, what is my actual difference we require, right? My actual difference is over here is what? And what is the actual difference square? Everything I need to sum and take the mean. So I sum all. I leave here one additional column to represent the labels, right? I leave a cell here. And what is this? This is going to be sum and this is mean, right? I take the sum of all. Yes, I take the sum of this. I put the formula is equal to sum of. I take sum of all these values. Similarly, I take average, that is mean of all these values. I got it. Similarly, I take sum of this, and sum. I take the sum of all this. So I find what is the sum of the difference, sum of the difference squared, everything I'm taking. Similarly, the mean also I'm calculating for each of these columns. I'm fixing what are the means also. So everything I was actually calculating. Then I'm going to proceed with my t statistic formula, right? So that formula for t statistics is t statistic formula is nothing but, let me first write the formula so that you can understand, you can keep in mind what is the formula. After that, we can actually use that formula for in the Excel sheet with respect to the Excel formula, right? The formula is be nothing but what is sum of the difference, right? The sum of the difference whole divided by square root of, yes, I write square, for square root I'll write SQRT, square root of, I need to take the standard deviation because this is going to be below thing is nothing but the standard deviation value divided by the degrees of freedom. So what I take now, for standard deviation we know that n into summation d squared minus summation d the whole square. That will be the standard deviation formula. So I take that here. That is n into sum of d. That is n into sum of d squared. That is this particular 480. That is this particular value minus sum of d the whole square. This every full formula will be coming. That is n into sum of d squared minus sum of d the whole squared, right? Whole divided by the number of degrees of freedom, right? I need to divide it all by the degrees of freedom. The square root is for the entire thing. So divided by n minus 1. Here the degrees of freedom is n minus 1. So this is actually the formula. That is sum of difference divided by square root of n into sum of d squared minus sum of d the whole square divided by n minus 1. D is nothing but the difference. I am saying difference as d. Also for a thing I'll make it this is nothing but d only, right? Sum of difference divided by square root of n into sum of d squared minus sum of d the whole square, right? So I repeat how to do that. If you are given a table like this, you should be able to calculate what is the difference between observed and actual, and take the difference squared, and find the sum and mean of the distribution. So now what you'll be doing, you'll be substituting here. I'll feed the formula here now. T statistics formula will be is equal to what is the sum of difference? Minimize somewhat. So what is the sum of difference here in the particular table? What is the sum of difference? This is difference, and what is the sum of difference?
48.
Great. Sum of difference is 48 divided by square root of SQRT of, I put two brackets because I know that there is a numerator and denominator. So in the numerator, what should come? N into sum of d squared. So we know the difference square is here. Sum of d squared. What is sum of d squared here? 418. And how many samples we have in n? This is actually, I can put a sample here. I can put a
10
sample.
samples.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 samples are there. So I can use that is equal to sum is equal to this particular thing. 48 divided by SQRT of, I'm having 10 samples, so I keep 10 here. So how many samples are there? You take 10 into d squared. Sum of d squared I need, so I take this d squared. So sum of d squared came minus sum of d. What is sum of d? Sum of d is I'm having here 48. This is actually sum of d, right? I take that also minus sum of d the whole squared. So I put sum of d 2 times, right? Then it should be divided by the degrees of freedom, that is 10 minus 1, that is n minus 1 the degrees of freedom. So I put 10 minus 1. So that is the formula over here, right? I'm having this. So if I give the this, I will post this Google it was this particular Excel sheet in the Google Classroom, so that you can easily feed any things with 10, or if you increase the number of samples also. So this will actually give you the T statistic result, right? Now I repeat, what is the thing with the formula actually? The sum of difference divided by square root of n into sum of d squared minus sum of d the whole square divided by n minus 1, right? So this thing you keep in mind so that it will be very clear on how to do those t statistics, right? Anyway, I will use my word and then paste the picture here so that the formula picture will help us more. Let me open the word. Yes, now my entire screen is visible, right? So in the previous classes, we have seen the student t test formula. This is what I have actually made in that Excel sheet. Summation d divided by square root of n into summation d square minus summation d the whole square divided by n minus 1. Can you see this formula here? Yes, can you see this formula here? Can you see this formula here? This particular formula. Can you see this?
Yes, sure.
Yes.
Yes.
So this is what we are the thing. I'll also paste this in Excel sheet so that when I share it to you, you'll be able to identify it what it is actually. This is also available for you just for the sake. So summation d divided by n into summation d square minus summation d the whole square divided by n minus 1. So this is the t statistic we got. The statistics is ready, and we know that whether to accept the hypothesis or reject the hypothesis, right? Now coming to the logic over here. Now we have the mean around 4.8. So now the question given to you. The question given to you is, if the hypothesis is blood pressure to be zero, blood pressure to be zero, whether blood pressure can be zero or not. So one hypothesis says that blood pressure will be zero. Another hypothesis says that blood pressure cannot be zero. That is the mean of blood pressure I'm saying. That is mean of blood pressure over here 4.8. That is the difference in those mean. What will be the effect? When I change it, there is no change in the sense, if it is 115 here, here also 115 will be there. There is 105 here, here also 105 should be there. So what is the possibility that the hypothesis for change in blood pressure, for change in blood pressure to be zero? Now we need to say whether this hypothesis is true to accept, or we need to reject the hypothesis. Right? This is what we need to say. So now what we will do, we will go to the T table. Now to the T table we will go and see whether to accept this hypothesis or reject this hypothesis. Right? Right. So far understood this, right? No doubts here, right? Is understood the question here, whether to accept the hypothesis or reject the hypothesis. The hypothesis here is there will be no change in blood pressure, or change in blood pressure will be zero, but actually is 4.8. Right? Shall we do this? Yes. My T table is over here, and I can use this T table for recognizing my values. Right? This T table also is available in it. I'll also post this. Right? Now we need to identify what will be the degrees of freedom. For this, how many samples are there totally? 10 samples. And we, when during standard deviation calculation, that is the denominator calculation, we took n minus 1 as degrees of freedom. Right? So n minus 1 is the degrees of freedom. So here what we have to take here, 9 is the degrees of freedom. Right? Am I correct? Right? 9 is the degrees of freedom. Now you go and check here where this 3.24 lies. Right? We can do it in two ways. I can set the confidence interval in the T table and then test whether it is within that or not. If it is greater than that, I can reject this hypothesis itself. This entire completely I can reject. Otherwise, where this hypothesis lies in the particular confidence level. Right? Now my answer is 3.324. Right? In the ninth interval, where 3.324 actually lies, you say me, where 3.324 actually lies, because the degrees of freedom is 9, I need to search in this row only where 3.324 is there. Where 3.324 is there, the closest range where I can find.
3.250 and
Yes,
4.297.
yes. 4.297 we need not go. My answer is 3.324. So it is in the range as 3.325, it is okay, and 2.8. Within these two ranges, it actually lies. Either it is going to be 2.821 or 3.3250. In this range, it will be actually available, right? So what is your t test thing is, I can also find what is my p value. I'll find next what is the p value, right? To find p value, what we will be doing, I'll put the hypothesis somewhat low. So let us find what is the p value. See the t table for degrees of, I'll put here, for degrees of freedom equal to 9. When degrees of freedom equal to 9, as you said, it is going to be in 3.250 or 2.821. In this range, it is going to be there. What is in the top? We have 1% and 0.5%, right? So my p value is going to be between 1% and 0.5 percentage. Right? My p value is going to be between 1% and 0.5 percentage. Right? So how can I write 1 percentage? 0.01 and 0.005. Am I right or wrong? My p value will be between 0.01 and 0.005. Yes.
Yes, the
Somebody
T
call.
value 3.32. Uh, We should take between 3.2 and 4.5 nurses.
Oh, sorry, I took what 3.2. So sorry, that is what. Sorry. I thought it is 3.2, less than that, right? So from 3.252, it is actually 3.32. Okay. So from 3.25 to 4.297. So it is actually between 0.5 and what is the next one? 0.1. Okay, 0.1. So 0.5 I can write it as 0.005 and 0.001. So between these, my p-value can actually lie, right? An approximate result, right? So in MCQs or something or some other quizzes in our open book test, if I give you what is the t-value, you should be in a position to say me what is the p-value and to accept the hypothesis or reject the hypothesis, right? Now, the question comes here. The hypothesis for change in blood pressure to be zero, right? Now, this p-value is actually 3.3250 states that we are having some hypothesis where the blood pressure value difference can be lying between 3.32 also, and the probability for that 3.32 to exist, the 3.32 change to exist is 0.0052 to 0.001. Between this, some probability is going to be lying, right? So this is the thing, right? Now if it is going to be the case, then what we should actually do, we should actually consider it in some different fashion. For example, if I was actually going to test that there is no change, now this is the probability that is very small, it is going to be 3.32. So the thing is, we can either accept the hypothesis or reject the hypothesis. So what I will do, I will check that if my hypothesis is at least greater than or equal to 0.005, I accept the hypothesis. So this is saying that 3.32 is going to be the change. And you are saying that the hypothesis for change in blood pressure to be zero. So what I can do, I can easily reject the hypothesis. That is one thing. Or I can actually, if I want to reject the hypothesis based on the threshold of p-value, I can set the p-value threshold as something like 0.005. It is greater, I can accept that 3.32 is the thing, but you are asking for 0, so I reject the hypothesis. On the other hand, what we can actually do is we can set the confidence interval from our way itself, right? If I set the confidence interval, then what should happen? This blood pressure change to be 0. If I normally set the confidence interval, it says that this particular thing will not satisfy my hypothesis. Why? Because mean is going to be 4.8, and for this 4.8 and a single tailed value. So this is actually one tailed t-test. So it is not having any negative values. So if it is having values like 4.8 or something, so we should reject that particular hypothesis. So I say that the hypothesis for change in blood pressure, I don't accept. I reject this particular hypothesis, right? Is it clear on how to calculate the p-value, or
Yes,
shall I
sir.
say? I'll say one more time. The t-test is most important. Like what will be given is you'll be given this particular table. You'll be given this table before some operation and after some operation. What will be the first step? Find the difference. Find the difference square. Calculate the sum as well as the mean. Right. Then we go for the formula application. We have the formula summation d divided by a square root of n into sigma d squared minus sigma d the whole square divided by n minus 1. So using this, I get this value as a t value as 3.324. I get the t value. So for this t value, I can find what is the p value. So what is the p value? P value says what is the probability of this p value to exist. What is the probability of this particular p value to exist, right? So we find the probability. So I set the degrees of freedom 9 and my t statistics is 3.32. So I go here, I come to the degree the freedom 9, and I can find that 3.324 lies between 3.250 and the 4.2, right? Between this, it is actually lying. So I can say that my t statistic is going to be over here and in this particular range, and and place my p value over there. So this is what the t statistics actually say. So the probability for this 4.8 to exist the mean difference between 4.8 to exist is 0.005 and 0.009. And the typical threshold value for p, not only because it is here 0.005, typically if a p value is greater than or equal to 0.005, I actually accept that 4.8 is true. That is the mean difference, that is the at least the difference to exist between the blood pressure before treatment and after treatment. After treatment, surely I'm expecting a 4.8 difference. So 4.8 is difference is going to be there, but you are saying that hypothesis that there is change in blood pressure to be zero. Surely this is not possible, right?
Yes,
Now, now let me ask a question, right? P value will be given. T statistic will be given to you. The T statistic value is nothing but 1.256, and number of samples will be 6. Number of samples will be 6. Now you find what is the p value. What is p value for this? How to find? If you say, I'll show the t table. How to find?
N minus 1 will be 5, sir.
Okay, so shall I show the t table?
Yes, sir.
Yes.
In degrees of freedom 5,
I think since it is randomly given, none of the value actually satisfies. But you can have at least have the closest value, that is less than 5 percentage, like that. So my value what is given is 1.256, where 1.256 will be closely related,
less than 5%.
less than 5 percentage. So I can say that it lies less than 5 percentage. Right? Now, if I'll give this is a thing. This now you can use it. And if I, as in question, without percentage, you put it without the percentage at 0.05, right? Now this is different, slightly different way. Now I include something. Let me see the t table also once. Yes. So immediately don't see the answer. Here the value is going to be minus. Only when I cross the zero in the quadrant, I can get minus. And if I want to cross my zero in my quadrant, then it should be two-tailed. So when minus comes, you are going to use two-tailed t-test. Now I say the number of samples. Number of sample is going to be 10. What will be the p-value? This is different from what you have seen already. Here the p-value should be calculated from the t-table only, but it is now two-tailed, right? So now going into minus 2.62, what will be the thing what I have to do now?
degrees of freedom 9, sir.
Okay, degrees of freedom 9, I went to here, and you see 2.62 is there. While seeing in the t table, you just don't remember the two minus, just to see here where 2.62 can be placed. Where I can place 2.62?
5%.
Between 5% and 2%.
2.62 pa. Okay, you are saying the two tail t test directly. That is 5 percentage and 2 percentage, right? Now this time you don't see this, you just see the double of this. That is between 5 percentage and 2 percentage. Why we are saying it is double? Why? Because if I draw the t test, both ends I will be seeing the values. If it is only single tail t test, only one end I will be seeing the value, right? So my p value will be between
5% and 2%.
5 percentage and 2 percentage. That is nothing but 0.05 and 0.0, right? This is how you need to estimate the p value, right? Now if a hypothesis is given, now the samples are not given, so you don't know actually don't know the hypothesis actually. Now if the sample is given like this, now I give another hypothesis for this big table. I give the table like this. When it is like my own cases are like that, I'll give a table like this. Now I'll say some other hypothesis, you say whether it is accepted or rejected. Okay, my hypothesis says that the change in the blood pressure values will be 5.8. Whether you will accept this hypothesis or reject the hypothesis. My value will be 5.8. Whether you will accept the hypothesis or reject the hypothesis. You just see what is the t value. T value is 3.32. What t value says? For the probability of 0.05, 4.8 is the mean change, right? So we say if 0.05 itself is a acceptable range for a particular a considerable change, right? Now I'm saying that the change in the observed values will be around 6.2, right? If I say 6.2, whether you will accept the hypothesis or reject the hypothesis, right? So I'll take a paint window and explain you that, right? I have a line here. Now this is going to be a 0, the mu and the mean values that is centered at the mean. Now if I draw the normal distribution curve for the student's t distribution, now what is the value I need to do? Say my t value is 3.32 here. So 3.32 may be something around here. So I say that this is going to be my distribution. So if anything falls in this, I say it is null hypothesis. What is this? 3.32. And what is the probability for this 3.32 data to exist is the p-value. What is p-value? The probability of the data to exist in this range is going to be the p-value, and that is going to be 0.0052 to 0.001, right? So I say that it is going to be p-value is g is equal to 0.0052 0.001. It is an approximate value, right? When you do this in a thing, you will be getting 0.008 actually, because this is an approximate measure, right? Now, if in software, if you do, you can actually find the p-value, but in pen and paper, we just take the approximate value, right? So the probability of the data to lie in this range is actually 3.32, right? Now, what value I gave actually to you? I gave a value 6.2. Whether 6.2 will lie here or not. Immediately you can reject the hypothesis, right? Because if you see in the observed values, I say that my range is actually around from 4.8, and whether I should accept the 6.2 or not. Now, when I say 0, it is actually somewhat around here. When I say 6.2, right? Now we should say on how much probability we should accept it and how much probability we should reject it, right? If it is in this particular range, it is actually, if it is in 3.32 range, then I accept the hypothesis, else I don't accept that particular hypothesis. Now coming to here, let me say one more time. For example, for this particular t statistic is 1.256, and the number of samples over here is, I have 6 samples. Now what I will do, for this 6 samples, I know that there is going to be some deviation between the observed and the expected values, and the strength of that deviation is going to be something like 1.256. And what is the probability for that deviation to happen is 0.005. What is the probability for that deviation to happen is 0.05, right? If you see here in the t table also, they will say it is a significance level. So the maximum significance what they gave is actually here is 10%, because changes will not happen more, right? A very small change, which actually is more than enough. So whether the change will happen or do not happen is what we need to say, right? So for this particular t value, if it is going to be like 6.2, we reject the hypothesis because it is going to lie in this particular range, which is actually considered as null hypothesis. Yes, I'll summarize one more time. See, I assume that a table was given to you. What you will do first? See, quickly say the answer. We will summarize quickly. Please answer quickly. Don't unmute and keep.
Difference, sir.
Great. First, you will
We
find the
have to find
difference.
difference.
Find
Next,
difference.
squaring the
Difference
Squaring the
square.
difference. Next,
We have to
Sum
calculate
average.
sum mean.
sum and mean. Up to this, very clear, right?
yes sir.
Yes,
Yes.
sir, clear, sir.
Now going to the formula. That formula is nothing but the what is the actual deviation divided by the standard deviation. This is actually deviation divided by the standard deviation divided by degrees of freedom. The how that we take here. So that formula we have feeded here, and we got the t statistics as 3.32. So that what t statistics are actually say, how much the expected and observed values are there, the difference. So this is actually the thing, the values before, and after applying treatment, what is my observed values, whether it is having a change or not. The mean change here is 4.8. For the witnessing that yes, there will be a change of at least 4.8, I'm saying that yes, it is going to have a t statistics as 3.32. Using this statistic, I can go to the t table. Here I go. My degrees of freedom is 9. Why degrees of freedom is 9? I'm setting. Why degrees of freedom 9? I'm setting.
N minus 1, sir.
Great. N minus 1
Nine.
is there. So, like Harini said, if I have 3.32, 3.32 actually lies between this zero single tiled. If it is negative, you can go for two tiled. Yes, in a single tiled t test, it will be lying between 0.5 percentage and 0.1 percentage. How much significant the change between observed and expected value is? My significance range is actually between 0.5 percentage and 0.1 percentage. So that I write it as a p-value. Probability for this change to occur is 0.5 percentage to 0.1 percentage. Is it clear or not?
Yes sir.
Yes, so far so good. Now going for given any hypothesis. Now the thing what we currently have is for the change to happen, the mean value 4.8. That is what we are going to check always. So the mean change is 4.8. If you get any blood pressure value, at least it will change by an average of 4.8. Why? Because my p value says that if it is going to change, my statistic is going to be 0.005 significant level. I say it is going to change because that much confidence I'm saying. 0.005 says that my confidence is around 97.99.5 percentage. I hope that much confidence level I'm saying that it will have a 4.8 value change, right? Now going to the table here, my 3.32 value is here, and my p value says that this is going to be the range, right? Now if you get anything over here before this 3.32, you actually accept. Otherwise, if it comes everything in this particular region, you reject the hypothesis. Now I get like something like 6.2 here, which will be lying over here. I'll have 6.2 here. So what I will do, I will reject the hypothesis. Why? Because my range for this to happen is 3.32 only. So 3.32 should be my value. If you take anything more than that, then I actually state it as a null hypothesis, meaning that that cannot happen. I cannot have the value as 6.2. Because if you say anything less than that, I can accept actually, because these are gray regions. But this red region I should not accept because my t value says that it should be before that, right? Now am I making it clear? Suddenly if I give any value like 10.2 change will be there in a mean value, I can say that whatever blood pressure is there after treatment, it will become plus 10.2. If I say like that, what you should say, you should reject this hypothesis. This thinking is wrong. You should not think like this. The normal change can be, it can be greater than or equal to. So if it is my two tailed says that it is from minus 3.32 to plus 3.32. It should be the range. And if it becomes two-tailed, what will be the thing? It should be multiplied by 2. So what will be the probability? This into 2, 0.012. What is over here? What is over here? 0.002. So if I give a particular range like say for example I give like 2, whether you will accept my hypothesis or reject my hypothesis. I'm saying that my hypothesis is after applying treatment, my blood pressure changes at least by 2, by an average by 2. You accept or reject the hypothesis.
Accepts.
Why?
Because less than 3.8.
That's all. That's all. Now, if I say now I'll give some other table. For that table, I say that randomly I give some values on the table. I change the values, and I say that after applying treatment, by an average, it should change by 6. So, what will be the procedure you'll be following? First, find the difference, difference square. Find the sum. Find the mean. Find what is the t value. Once you fix the t value, go and see the p value, right? Now the p value is actually around some 0.005. If it is 0.005 itself, it is somewhat significant only. If it is less than 0.005, don't, then you say that your t statistic is not good, right? T statistic is not good. If it is 0.005 and more, you accept. Okay, this t value is good. With this t value, you can actually do some hypothesis testing. Once you find the t value, if I say any value greater than this, you reject. If it is any value less than this, you accept, right? With the probability of p value.